My name is Victor Odigoma here. In our class today, we are going to be looking at a very, very important expression, one of the laws of logarithm, It is called the inverse law. The inverse law. All right. In this inverse law says that logarithm of x in base a is equals to 1 over log. When you now take the inverse of logarithm of this interchange, it will now be log a in base x. Sometimes they call it change of base formula. The change of base formula. All right. So you realize that the logarithm of x in base a is the same thing as the inverse of the logarithm. You now change the base, the logarithm of the base. Now x becomes the base. I don't know if you understand what I mean by that. The base becomes the number and x becomes the base. Do you get that? Let's not blow too much grammar. You are going to understand this thing in real application, as I'm going to use a specific example to illustrate this. Now you are going to capture what I'm trying to say. All right. So if you come here, you look at this. Can we figure out something and say, can we use log 27 in base 3? Log 27 in base 3 to show this. What is log 27 in base 3? Log 27 in base 3 is, let me do it here. Log 27 in base 3 will be the same thing as 27 is 3 raised to power 3 in base 3, and that will give us 3 log 3 in base 3, and the answer is 3 times 1, which is 3, because logarithm of a number to its base is 1. So 3 times 1 will give us 3. So it then means that log 27 in base 3 is 3. Okay, can we use this? Can we now show that? Can we now use this to buttress this, to affirm that this is true? Let me come like this. Log 27 in base 3 is the same thing as the inverse of log. It will now be, the base will become the number. Then I have 3, and the number becomes the base, 27. Is this equals to this? Let's find out. You now say, but let's come from here, this. But log 3 in base 27, let it be equals to x. Okay? So you know our method. So we can interchange them, and we have 27 raised to power x equals to 3 raised to power 1. And this is 3 raised to power 3. Multiplying the existing x, the power there, which is this, equals to 3 raised to power 1. Now, since the base are equal, you will have 3x equals to 1. And this, divide both sides by 3. You are going to have x will be equals to 1 over 3. 1 over 3. Wow! It then means that, you know that this one is 3. You know, we have shown it that this one is 3. Equals to, wow! So this one, this which is x, we can bring it here and say 1 over 3. If you take the inverse of 1 over 3, what is it going to give you? It will give you 3. It will give you 3. Wow, that's wonderful. So this, when reverse, is 1 over 3. But if you take the inverse, it will give you 3. Have we been able to show that whenever you have log x in base A, that it is the reciprocal, the inverse of log then A in base x. Yes, we have been able to show that right now, that this will give you this. So I'm trusting God that this is a very good explanation to someone out there on the inverse law. Remember, we are looking at the theory of logarithm. This is a good explanation on the inverse law. That is to say that if you have a problem like this, that you can take the inverse of it, with the base and the number interchanged, that the answer you are going to get there will be the same thing as the logarithm of this, the logarithm of x to its base a. So I'm thinking that this explanation is good enough and can guide you out there in usage and in application. Thank you for being there. Please like our video, share it to someone there, and click on the subscription button and on the notification button so that you can be able to, get updated with the videos we'll be making as time goes on. We'll get more questions, strong questions that can back up what we are saying here. And I'm trusting God that this is going to help you so much. Thank you for being there.